Chapter 13, Speech Perception. So let's review. Sound, the thing that we listen to, the acoustic signal, is produced by moving air. Now, the way we produce sound, with our voice, is by pushing air up from our lungs and forcing it through vocal cords that are in our vocal tract. Um, we of course have a lot of control over the flow of air through the vocal cords, how they're stretched. Of course, the movement of our lips, our tongue, our jaw, and the diaphragm muscle that controls the flow of air to produce speech. So all of these components work together to produce speech. We produce vowel sounds, and if you notice, vowels all have these particular long sounds like A, E, I, O, U. Vowel sounds are all produced by vibrating the vocal cords and changing the shape of the vocal cords. Other letters, other sounds are produced by manipulating the tongue and the lips to produce different sounds. But vowels are produced simply by the vibration of the vocal cords and changing the frequency and the pitches and whatnot. This slide here has a cutaway of your head. It should be pretty obvious where all the parts are. But one of the things you should notice, and one of the things you should take home with understanding this, is all of this from the larynx all the way up into your nose and your lips. All of these components work together to help us to produce speech. It's not just our vocal cords, or it's not just our lips, it's not just our tongue. All of these parts have to work together to allow us to produce spoken words. This is why it has been very difficult or it's impossible, I should say, not difficult, impossible to get other species like chimpanzees to talk. They can't talk. They do not have the apparatus in their head and in their neck and in their chest to produce speech. So whenever you see these animated shows with talking animals, it's impossible. um, so each vowel sound has a series of particular sounds that are put together to create it. And these sounds are known as formants. Formant. Not format, formant. It's described in your textbook starting in page 318 under the section called the acoustic signal. The first formant of any vowel sound has the lowest frequency, and then the second formant has the next highest frequency, etc., etc., etc. We can have people pronouncing vowels and different vowel like a or a, and then looking at sound spectrograms to see which frequencies and the intensity of each frequency is used to make up and produce that sound. Consonants, so like B, K, V. Consonants are created by creating blockages in the vocal tract. Okay? So, in other words, to produce the word B, what you have to do is put your lips together, B, like this, B, and then do an explosive release, B. K, if you say the letter K, you'll notice that you're putting your tongue in the back of your palate and then releasing it. So consonants are produced by constricting different parts of the vocal tract, whereas vowels are produced simply by vibrating and combining certain frequencies together. A formant transition is when you quickly transition across the formants that make up a word or phrase as you go into a consonant. So, for example, if I say at, I'm starting with a vowel sound, a, and then t, at. That's a four-mont transition. When I the frequency change when I go from at, that frequency change is the four-mont transition. Here, for example, is um, uh, the the vocal tract pronouncing the letter L. L. No, I'm sorry. That's an I. That's an I, as in zip. Zip. And this right here is the U as in put. Put and zip. I, oo. Notice, if you look at this side view of the vocal tract, that there's no blockage of any part of the pathway. It's just we're simply changing the shape of the vocal tract, and this change in shape, along with the change in the way the vocal cords are vibrating, causes a different set of frequencies to be expressed. The I is these frequencies, and the are these frequencies right here. Um, Speech is made up of a series of basic units. The smallest unit of speech is one that is called the phoneme. The phoneme. Every language has different phonemes that are associated with it. English has 47 phonemes that are used in producing American English. There are 13 major vowel sounds that we use and 24 consonant sounds that we use. Um, this varies tremendously from language to language, and the categories of phonemes vary from language to language. So, for example, in German, which is a very harsh language, or Hebrew, or German, these are languages that have a lot of guttural sounds, like where the speech is coming out from behind your throat. Um, um, Japanese has a lot of long buzzing consonants, phonemes, I should say. So these different languages have a series of different phonemes, and one of the things you learn as a baby when you're listening to speech, even when you're inside your mother's womb. When you're listening to speech, one of the things that you're acquiring and you're learning about are the phonemes. By the time you're about 6 months old or so, you've already learned all the basic phonemes that you're going to need to produce the speech that you're going to use when you're growing up. This right here is a frequency spectrograph, and basically what you can do is to run the speech through a spectrograph that analyzes the signal for all of the frequencies that appear inside of the signal. The dark spots that you see are the points where the frequencies are very strong, and the lighter areas are where those particular frequencies are very much weaker. So, for example, here, this very dark spot right here is telling us that there's a lot of frequencies here that are between, say, looks like maybe around 250 and 1,000 hertz. Um, Now you'll see Roy, red, the will. And one of the things that you'll note here are the transitions. These transition parts right here, where the frequency is all of a sudden going up into the formant. When we say the word red, is a vowel sound. Red is a vowel sound. The ea together makes a vowel sound, and these are the three formants that create that vowel sound. This lower one here, the next higher one, and then the next higher one. Notice that in the two higher ones here, there's this transition frequency, what we talked about earlier, these frequencies that allow you to transition from a vowel sound, which in this case is the R, red, um, and then there's the abrupt D, right? because a D is really just a block, right? So it's going to say red, and you're not going to see a lot of frequencies here for D because what we're doing to produce the D is simply blocking the production of the, stopping the production of the eh sound that's here. These are the consonants and vowels of English and their symbols that are used, right? So, for example, this is the V, vet, and this is the phonetic symbol that's used to represent vet. Let's see. So here's hot, ah for hot, o or for sofa, many, a for bait, e for head, a for had, hood, oo, p, but, boat, bought. All of these different, these are all the different basic sounds, the fundamental building blocks of our speech. And there's a few others besides this. These are the main ones. There's a few others in American English besides these. British English has some slightly different ones, of course, because Brits do pronounce a lot of words differently than we do. But for the most part, these are the basic English sounds, that the phonemes. So here's one of the problems, or one of the fundamental issues when you're dealing with uh, trying to parse phonemes, trying to understand phonemes. There's no simple correspondence between the acoustic signal, in other words, the sound that's being produced, and the individual phonemes. In other words, I cannot reliably produce the same exact sound and put it into different, let's say, put it into different words, and expect people to perceive the same thing. And the reason for that is because we use context to interpret to interpret acoustic signals as well as the sounds that we're producing. So in other words, I could be saying a phrase. So I could be saying a phrase. So say a, that sound a. If I were to make that sound in another context, if I were to say Ray Lopez, which is my name, you might perceive the A in Ray and the say in saying as different. It depends. I wish I could come up with a better example than that. But really, my point is that the exact same vibrating sounds that are traveling through the air are going to be interpreted differently based on the context. The other problem, the other cause of variability is what we call co-articulation. When we're talking, especially when we're talking really quickly and talking fast, there's overlap between the way the phonemes are articulated. So one of the and this is the cause of one of the this is one of the causes of different accents and dialects that you hear, um, from different regions in even in the same language. So, for example, if if a if somebody from the north were to say howdy, they would say howdy. Somebody from Texas would say howdy, howdy, and hattie. Notice that the howdy and hattie, those are two completely different sets of sounds, especially in the middle, right? The howdy, and hattie. Um, we're producing two completely different sounds, and we're mashing them together in different ways, right? So not only do we have the different sounds, but also they're also being articulated in different ways.